So now we're going to do another example of finding the x-intercepts of a quadratic. In this case, we have the quadratic x squared plus 9/2 x minus 5/2 equals 0. So the first thing that I recommend for you to do is to identify what your coefficients are going to be. So in this particular case, we know that our a, the coefficient of the x squared term, is 1. Our b, the coefficient of our x term, is 9/2. And we know that our c, the coefficient of our, the constant term, in fact, is negative 5/2. And then, as before, I recommend that you begin by writing down the formula. In our case, we have it here as a reminder, but I want to pretend that in your case, you have this on an index card or you already have it memorized after a certain point. Not yet, because this might be the second time you've seen it, but over the course of time, I want you to memorize it. So, but in any case, I want to write it down first. I want it to guide us as to how we're going to solve this problem. So this is our formula, and now we're going to start plugging in the values. So we're going to have negative 9/2, because the 9/2 is positive over here, but we're going to have to take the negative of it, and the negative of the positive is just a negative, plus minus the square root of our b squared, which will be the 9/2 squared minus 4 times our a, which is 1, times our c, which is negative 5/2. And then all of that is going to be divided by 2 times a. A is 1, so 2 times 1 is just 2, so all of that will be divided by 2. And so now we need to start to simplify this. And to do that, I'm going to first simplify what's inside of this square root. So I'm going to do that here. 9/2 squared minus 4 times 1 times negative 5/2 is going to equal, I'm going to go step by step. We know our order of operations. We have to take into account our order of operations. Parentheses, exponent, multiplication and division, addition and subtraction. In this case, we're going to do this exponent first. So what is 9/2 squared? That means 9/2 times 9/2. So let me write that down here. 9/2 times 9/2 minus 4 times 1 times negative 5/2. We can see that 9 times, when we multiply fractions again, I want to remind you, we just multiply the numerator with the numerator and the denominator with the denominator. So we get left with 81, because that's what 9 times 9 is, over 2 times 2, which is 4. And then over here, let's look at this. 4 times 1 is 4, times negative 5/2 is negative 20/2. So we're going to have minus negative 20/2, which is plus 20/2, like this. And now we're adding two fractions with a different denominator. But we can see that 4 is 2 times 2. So what we're going to do here is we're going to multiply this fraction by 2/2. And that gives us 81/4 plus 40/4. And this then gives us, when we add up the 81 and the 40, 121/4. So we can now take this calculation that we did over here, and we can rewrite that over here. And that is the following. Negative 9/2 plus or minus the square root of 121/4 divided by 2. Now I want you to notice how when I'm doing certain parts of this calculation, I'm segregating some complicated parts over here to a separate part of my board. And I recommend that in your case, you do the same thing, whether it's a separate part of your paper or a separate sheet of paper to do scratch calculations. That way, you can make your calculation, your main calculation, as clean and as clear as possible. So now, I want to explain something about this square root here. So I'm going to erase this calculation here, so we can use this space again. Okay. So we need to know that whenever you take the square root of a fraction, let's say you take the square root of x divided by y, this will give us the square root of x divided by the square root of y. Okay? In this case, the square root of 121 over 4 is going to give us the square root of 121 divided by the square root of 4. The square root of 121 is 11, and the square root of 4 is 2. So we can finally rewrite this part as equal negative 9 halves plus minus 11 halves over 2. And we're finally in a position where we can actually get the two x-intercept values from this equation. And I'm going to carry that calculation out over here just so that the board stays like, just so I don't lose the train of this calculation on the board. I don't want to erase where we've come from here. So now, when we take the plus part, we're going to get x equals negative 9 halves plus 11 halves over 2. And this will give us 2 halves over 2. Which will give us 1 half. And so we can already write over here one of our solutions. Let me put them over here, just for convenience. X equals 1 half. And now, when we do the negative part, we're going to get x equals negative 9 halves minus 11 halves divided by 2. In this case, it'll be negative 20 over 2 divided by 2, which will give us negative 20 over 2 will be negative 10. So it'll be negative 10 over 2. And that finally gives us negative 5. So we can finally write over here x equals negative 5. These then are our two x-intercepts. That if we were to graph this quadratic equation, y equals x squared plus 9 half x minus 5 halves, we would get the crossing of the x-axis at these x values. Voila! It's wonderful. Now we mustn't forget one of the habits I want you guys to develop, and that is our pro tip: check your answer. So we got these x-intercepts when we were solving for this, when we were solving this equation. So what I'm about to do is I'm about to check them to make sure that we got the right answer. And I want you guys to get into this habit also, because every single one of us is prone to make a mistake, and this is a way of us avoiding that. Okay, so our equation is x squared plus 9 half x minus 5 halves equals 0. This is what we want to test. So I'm going to plug in x equals to 1 half into the left hand side, and I'm going to see if it equals 0 at the end. Okay, let's do this. So 1 half squared plus 9 halves times 1 half minus 5 halves. Okay? So now this will give us, we saw again, what does it mean for us to square something? It means for us to multiply that thing with itself. So in other words, it'll be 1 half times 1 half. Okay, let's do that. 1 half times 1 half. Like this. Beautiful. And then it'll be plus 9 halves times 1/2 minus 5/2. Now here, we can actually multiply it. 1 times 1 will be 1. 2 times 2 will be 4. Here, we're going to have plus 9 times 1 is 9, over 2 times 2 is 4, and then here we're going to have minus 5/2. Now here, this, if I have 1/4 and I add 9 quarters, I have 10 quarters total. So that's what happens here. This is going to be 10 quarters minus 5/2. Okay? And now I'm going to finalize this problem over here. So I'm going to bring this up here. I'm just going to copy it. And then I'm going to continue the calculation here. So 10 quarters minus 5/2. And I ask myself, can I multiply 2 by a number to get 4? So that I can get the 5/2 to have the same denominator as the 10 fourths. And indeed I can. If I multiply 2 by 2, I get 4. So in this case, I'm going to multiply the second fraction by 2 over 2. Now, if I do this, then I get the following situation. I get 10 fourths here minus 2 times 5 is 10, 2 times 2 is 4, and I see that indeed, when I plug in our first x-intercept into our original equation, we do in fact get 0. So we have verified that this is in fact a solution to our original problem. I will now do the same thing with the negative 5. Okay. This is so exciting. La 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 la. Okay, there we go. So now we're going to have, okay, negative 5 squared plus 9 over 2 times negative 5 minus 5/2 equals 0. Okay, let's see. So negative 5 squared means negative 5 times negative 5. Okay? Then this part plus 9/2. Now this negative 5, I can rewrite it as a fraction by writing it as negative 5 over 1. And then minus 5/2. And this, oh, we shouldn't put that in equals 0. Right? We don't know that yet. This equals that for sure though. Now we want to see what this equals to. Well, let's begin. Negative 5 times negative 5 is 25. Positive 25. Because a negative times a negative is a positive. Now here, when we multiply these fractions, it's going to be 9 times negative 5, which is going to be negative 45, divided by 2 times 1, which is going to be 2. And we're adding it, so we're going to get a plus, minus, and that becomes a minus. So it's going to be minus 45 over 2. Finally, we're going to get the minus 5/2 over here. Minus 5/2. And now I need to ask myself, okay, can I write 25 as a fraction with 2 in the denominator? And let me show you how we're going to do that. We can first of all write 25 as a fraction by writing it over 1. And if you remember from our original lectures, we asked the question, can we find an equivalent fraction with the same denominator as a given fraction? In this case, we want the denominator to be 2. And what we said was, to get an equivalent fraction, we would multiply by a fraction that equals 1, but so that the denominators, when they multiply, they give you what you want. In this case, the answer will be 2 over 2. Because this fraction equals 1, and when we multiply the denominators, we're going to get the denominator we want, which is 2. So that'll be 50, because 25 times 2 is 50, divided by 2. Okay, so now we know that we can replace this 25 with 50 over 2. And so that gives us 50 divided by 2 minus 45 divided by 2 minus 5 divided by 2. Let me put a little bar here. We can see 50 over 2 minus 45 over 2 is going to be 5/2. And then we're going to subtract the 5/2. Because what I did was I did this calculation, which is the 5 halves, and then I put the negative 5 halves because it's still there. So this equals that so far. And then of course 5 halves minus 5 halves is of course 0. So we have just finished verifying that both of the roots that we got, both of these x-intercepts, are in fact the correct value of the x-intercept. Ta-da! It's wonderful.